Good day. Today, we will be conducting an experiment regarding static electricity. I am Danielle Luis Magura, and together with my members, Mariel Abusmas, Bernice Leyva, Suzanne Montegudo, and Luis Tolentino, we will be redesigning the gold leaf electroscope experiment. The objectives of this study are as follows. First, to be able to describe static electricity. Second, to create and redesign an electroscope to detect electric charge. Third, to study the positive and negative charges that can accumulate on matter. Fourth, to explain how the principles of induction, conduction, and grounding apply to the electroscope. Fifth and last, to be able to observe that like charges repel one another while opposite charges attract one another.
A scientific principle called static electricity, or the buildup of charges, is responsible. All physical objects are made up of atoms. Inside an atom are protons, electrons, and neutrons. The protons are positively charged, the electrons are negatively charged, and the neutrons are neutral. Therefore, all things are made up of charges. Opposite charges attract each other, negative to positive, like charges repel each other. Positive to positive or negative to negative. Most of the time, positive and negative charges are balanced in an object, which makes the object neutral. Static electricity is the result of an imbalance between negative and positive charges in an object. These charges can build up on the surface of an object until they find a way to be released or discharged. One way to discharge them is through a circuit. The rubbing of certain materials against one another can transfer negative charges or electrons. For example, if you rub your shoe on the carpet, your body collects extra electrons. The electrons cling to your body until they can be released. One way to detect electric charges is through the device called an electroscope.
The following are the materials for today's experiment. A glass, a glass lid with a hole in the middle, 2 inches of plastic straw, 10 inches of copper wire, 2 pieces of 2 inches square aluminum foils, pieces of paper, a balloon, a pen, and a styro ball. Start by punching a hole in the jar lid large enough for the straw and copper wire to fit. Then, insert the straw into the hole and center it. After that, bend an inch of the copper wire into a hook to hold the aluminum foil later. Use the pliers to bend the remaining copper on the top of the lid into a coil to provide more surface area. Now, cut a small slit in the aluminum foil and slide them onto the copper hook. Then, you can now attach the lid to the jar. Now, rub the balloon on your hair. After rubbing the balloon on your hair, you can now place the balloon next to the copper coils. Observe what happens to the metal inside the jar. Now, move the material away and touch the coiled wire. Observe what happens. Repeat procedures 7 and 8 for any materials you would like to test.
For the data and results, materials, rubber balloon and human hair in paper. Electric charge, both the balloon and human hair acquired the same charge. They both became negatively charged. Based on observation, the balloon acquired an electric charge after rubbing to human hair. Upon placing the balloon on the wire circle, the two strips of paper strongly repelled. The balloon was brought closer to the wire circle and the two strips of paper again visibly separated. Materials: rubber balloon and human hair in aluminum foil. Electric charge: both the balloon and human hair acquired the same charge. They both became negatively charged. Based on observation, the balloon acquired an electric charge after rubbing to human hair. The two aluminum foil strips inside the glass strongly repel each other, but on the time that the wire is touched by a finger and then tries to place the rub balloon near the wire circle again, it shows that the aluminum foil strips repel slightly, only a few distance apart, but it is still noticeable. Materials: styroball and human hair. Electric charge: both the styroball and human hair acquired the same charge. They both became negatively charged. Based on observation, the balloon acquired an electric charge after rubbing to human hair. The two aluminum foil strips inside the glass repel each other lightly. It shows a minimal reaction and there is a movement apart, but it is not that far. Materials: ballpen and human hair. Electric charge: both the ballpen and human hair acquired the same charge. They both became negatively charged. Based on observation, the balloon acquired an electric charge after rubbing to human hair. The two aluminum foil strips inside the glass repel each other lightly, just like what happened in the case of rubbing the styroball and human hair. The reaction between ballpen and human hair is weaker than the reaction happened in styroball and human hair. For the interpretation, based on the experiment itself, it doesn't escape from our observation that when two materials are rubbed with each other, one material that is placed near the electroscope loses its electric charge seconds after it has been rubbed for on the first trial that the material is placed near the copper wire circle. There is a noticeable movement of the aluminum foils where they strongly repel, and as seconds have passed, when the balloon is continuously placed near and away from the copper wire circle, it creates a minimal reaction in the end until there is no more reaction. The results show that the materials used, which were balloon, styroball or polystyrene, and ballpen or plastic film, are all negatively charged based on the illustration or set of positively and negatively charged materials on the original experiment.
Conclusions. Static electricity has a wide range of uses and applications which can aid us in today's generation, especially with the fast-paced advancements we have. Both the original experiment and the researchers' redesigned experiment exhibit strong repulsion of the paper strips and aluminum foil strips. The materials with the greatest ability to hold charge will cause the pieces of foil in the electroscope to move the most. Electroscope is helpful in detecting electric charges since we can know if a certain material has an electric charge or not. We can make our own electroscope using things that can be found in our house or other alternatives instead of using laboratory equipment.